sir, I will drop off. The entire screen will be yours. You introduce yourself, and then I will put this. I will add the PPT onto the stage.
So people are there. It's 7:18. We are supposed to start, or we need to wait?
No, no, we will start, sir. We will start, sir.
We'll start. Okay.
Yeah,
Okay.
yeah.
Fine, fantastic. Hey,
Sir.
good evening, everyone. Welcome to this fantastic session of building your own Copilot, custom Copilot with Semantic Kernel. I'm your trainer today. I'm Krunal Trivedi. Let me start the session with my brief introduction. I'm an MCT Microsoft Certified Trainer as well as MCT India Regional Lead. And this is my 7th year as a Microsoft MVP for Azure as well as AI now. In my daily life, I provide trainings and consultancies for various IT MNCs around the globe. And I'm doing this thing for last 15 years now. So we are going to understand how to create custom AI agents, which helps you to work with LLM, and you can get your business or you can say your enterprise application ready with it. So yeah, we are going to start it now. So what we are going to do is we are going to understand a couple of things here. We are going to understand what is LLM. We are going to understand the power of AI agents. We are going to understand prompts, why we need prompts and effective prompt engineering. We are going to understand tokens. We are going to understand semantic kernel. And then we are going to write an application having all these things together, right? So again, this is what the detail. You can see my LinkedIn URL, you can see my email address, you have the scanner also, my book is there, right? So feel free to reach out to it. Reach out to me in case of any queries, any question later on, or join me over the LinkedIn. So friends, first of all, what is semantic kernel? So as we all know that semantic kernel is an open source SDK that empowers developers to build their own custom artificial intelligent agents. So let us start it with the discussion. Let us start it like this. So we all know we have LLMs like OpenAI, LangChain, and few other LLMs are there like Hugging Face, right? What this LLM does, they are trained over huge public data. They are superpower. They are super rich in terms of capabilities. We can use these LLMs to generate summary, to draft an email, or it helps you in your day-to-day life to create presentations, help you when you ask some certain type of questions, right? For chatting. So it is very powerful. Models are there. Now sometimes you need to build your own LLM kind of agent, because already we have GPT-4, GPT 3.5, we have Hugging Face, we have Llama, we have embedding models. They all are there. Now you want to write your own application in your enterprise boundary, which takes input from you, having some predefined set of rules, and then talk to LLMs and gets you the data. And here semantic kernel comes to the picture. So again, As I told you, Semantic Kernel is an open source SDK that empowers developers to build their own custom AI agent. By combining LLM with native code, developers can create AI agents that understand and respond to natural language prompts to complete a variety of tasks. So, this software piece, what you are going to write, you can write this software in C sharp, you can write it in Java, you can write it in Python, right? As of now, Semantic Kernel supports these three languages, first of all. So you can write your custom software which 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 can do certain amount of task, which can do certain task, and which talks to LLM behind the scene to get some help. Now, if we go back, and you can see we have artificial intelligence, right? So in early 1950s, the field of computer science design, and this is what here, uh, which create intelligent machines that can replicate or exceed human intelligence. Later on in 1970s, 1997, we get a subset of artificial intelligence which is machine learning, and which enables machine to learn from existing data and improve upon the data to make decisions or predictions. In 2017, we get one technique called deep learning, in which layers of neural networks are used to process data and make decisions. And then in 2021, we get Gen AI, generative AI. Here, the intention is to create new written, visual, or auditory content based on prompts or existing data. Now, today we are talking about semantic kernel, which is, you can say, extended part of generative AI. So where you can integrate this generative AI, these LLM models to your application. So the role is what? You are writing some, say, travel agent website, or you are writing some of your enterprise application. In that application, you want to integrate the power of LLM, and that you do using semantic kernel. So semantic kernel helps you to integrate LLM with your piece of code. Say we have something called AI agents. What is AI agents, friends? So these AI agents is a program that can achieve predetermined goals. They are powered by LLMs and that are trained on massive amount of data. So you are going to write this AI agent now. An AI agent can fulfill a wide variety of tasks with some of the minimum human interventions. For example, we can use AI agent to write code, to compose emails, summarize meetings, provide recommendation, and list goes on. Right. Now here, I want to get functionality or capabilities of LLM, and that capability I want to integrate in my code, my piece of software that is known as now AI agent. And for that, we are going to use semantic kernel. So semantic kernel integrates LLMs like OpenAI, Azure OpenAI, Hugging Face with your conventional programming language like C Sharp, Python, Java. Developers can create plugins. So in semantic kernel, that piece of software, the small tool, small task what it achieves is known as plugins. So developers can create plugins to interface with LLMs and perform various tasks. The semantic kernel SDK provides built-in plugins. For example, your task is to retrieve current date and time, or your task is to schedule something after 2 days or after 5 days. So you need current date and time, right? So that's why we have one plugin available. Or say you want to talk, you want to do some conversation, you want to create a chatbot, right? And you want to understand natural language. So you need some plugin there, right? Or say you want to fetch something from the GitHub, right? Say this is the username is Krunal, is GitHub handler is this, and retrieve all the popular repositories of Krunal. So that is what you need, some built-in plugins. So the semantic kernel SDK comes with built-in plugins And even you can create your custom plugins here. That is nothing but the some sort of functionality, some sort of task here, right? Developers can easily utilize LLMs in their own applications without having to learn the internals of the model's API. Now understand, friends, say you are writing your code in C Sharp and you want to use, say, Azure OpenAI's GPT-3 or GPT-4 model. So you need to understand how to talk to Azure OpenAI's GPT-3 and GPT-4 model. Along with that, you need to understand classes, interfaces, functionalities provided by GPT-3, GPT-4. Tomorrow you are going to connect it with the Hugging Face. You are going to connect your C Sharp or Java code with the Hugging Face. So you have to understand, like, how to connect to the Hugging Face and what all are the classes, interfaces, building blocks provided by Hugging Face. And as we don't want to do all these things, what we do, we use semantic kernel here. So you are not going to learn the internals of these LLMs API, right? You are just going to talk to semantic kernel SDK. And then semantic kernel SDK allows you to connect to various LLMs with the help of their API here. The key component, as you can see here in this diagram, is the semantic kernel SDK itself. We have plugins, we have connectors. So this semantic kernel part is also known as AI orchestration layer. So the core of the semantic kernel stack is an AI orchestration layer that allows seamless integration of AI models and plugins. And this layer is responsible for combining components to craft innovative user interactions. So we have connectors. So semantic kernel SDK offers a set of connectors that enables you as a developer to integrate LLMs to your existing application. So you are writing your Java project or you are writing your C# application, and now you take input from the user, and your user says, I'm going to travel to France and I want to prepare my itinerary. So what you can do, you can take this input from your user with the help of your C# web application, and now that input you are going to pass to LLMs with the help of connectors, and then you get some response over there. And plugins, as I told you, this SDK operates on plugins, which serves as the body of this artificial AI agent app. Plugin consists of prompt that you want the AI model to respond to, and functions that can complete specialized tasks. And even you can create your own plugins, small functions, or you can use built-in plugins here. Now, why semantic kernel, friends? So again, as I told you, it provides the layer of abstraction. So the semantic kernel SDK is a valuable tool for adapting AI into your application. So it simplifies the challenges of calling direct API, or it cut down on the learning curve that you are not going to learn the internals of various AI models, and it incorporates latest AI development here. It offers a streamlined pathway for developers to quickly create new AI solutions or enhance existing products and applications. As I mentioned here, we have three key features or three reasons we should go for semantic kernel. The first one is streamlined integration. So it simplifies integration of AI capabilities into existing applications with the various functions, connectors, and SDK blocks. The second one is reduced learning curve. So no need to learn the APIs of the LLMs. I mean, no need to spend your time to understanding what is the intricacies of OpenAI or Hugging Face or any another AI model over there. And the third one is enhanced reliability. The semantic kernel SDK supports the ability to fine-tune prompts and plan tasks to create control and predictable user experience. Now, as we all know that prompt engineering is very important thing when you work with generative AI, right? So if you want a predictable output, you have to write accurate, clean, clear prompt, right? You should have clear instruction, you should have clear set of examples provided, and as a result you have to set the context, you have to set the role, how this AI agent is going to work, and as a result you get predictable output. So with this semantic kernel SDK, even you can control your prompt, you can control the prompt of the user, right? And it helps you to get predictable output. You can control the number of tokens, you can control the parameters, the randomizations like temperature parameter or top p parameters. So a lot of things we can control with the help of this SDK here. Now let us see how to build this semantic kernel application. Say this building your application or integrating semantic kernel to your application takes very minimal steps. You have to start with writing your own piece of code, which is now we say AI agent, and you need to integrate semantic kernel SDK to your application. It's just nothing but the NuGet package. If I talk about C#, I have to use NuGet package manager. I need to get that semantic kernel SDK into my .NET application or .NET Core application, right? And this SDK uses the endpoint to connect to the LLM and to run your prompts. As I told you, semantic kernel SDK supports Hugging Face, OpenAI, Azure OpenAI, right? And conventional programming languages like C#, Java, as well as Python. You can see in this diagram here, so this code is in the C#, and I have used semantic kernel version 1.2.0. So first of all, you can see you need to add this semantic kernel to your project. So if we are working with .NET Core, we can use .NET add package Microsoft.semantic kernel, and we just provide the version over there. Then here we have a class called kernel, and we have a function called create builder. And here you can see I provide my chat completion endpoints. It's like, I want to use Azure OpenAI chat completion API, chat completion LLM behind the scene. So we need to provide deployment name, endpoint, API key, as well as model ID. So what happens, you just go to your Azure portal, you just search for Azure OpenAI, you create your model there. You can use GPT 4.0 or GPT 3.5, GPT 3.5 Turbo, according to your need. And that endpoint key as well as the deployment name you are going to connect here. And then you just call this build function of the builder, and that's it, right? So this is how we can integrate semantic kernel to our code. And it's very easy, just bare minimum thing you need, installing semantic kernel SDK, and then you need to provision Azure OpenAI service over there. You need to create deployment model on the Azure OpenAI service, and then you just provide key and endpoint, and finally you just write your piece of code here. Even you can see if I further continue it, so we just have a function called invoke prompt async. With the help of this function of semantic kernel, invoke prompt async, you can connect or you can send your prompt that you take from the user to your OpenAI models, and then it generates output for you. So let's see a demo quickly. So yeah, what I'll do is I'm here in my VS Code, and let me just go to terminal. I just go to view and terminal. I just go to desktop here, and I create a new directory, this semantic kernel demo. I just go to that semantic kernel demo directory, and here I'm going to create new project for the .NET Core. So what I'm going to do is I'm going to fire a command which helps me to create a new .NET Core project. So, and I'm just going to create a new console application. So I just write say .NET new console and say create a project open. I just say semantic kernel project season of AI demo. So this is what I'm going to create new .NET console application, and it's creating the project for me. Yeah, the application is created. I just navigate or say let me just go to my folder structure here, and from the desktop I just write say SK project a semantic kernel demo inside that SK project. Yeah, so I'm here inside my project structure now. You can see as of now it is pure .NET Core console application, nothing else. And next step is what? We need to add our semantic kernel package here. So what I do, again, I just go to terminal, and to add the package, I'm going to use .NET add package. And my package name is Microsoft semantic kernel I want a version 1.2.0. So yes, you can see it's storing the package here. It's installing the package. If I just go to my CS file, and you can see in the item group we have the package reference, which is Microsoft Semantic Kernel version 1.2.0. So yeah, that's it. We are all set. We are all set here, right? Like now, I can even show you. I have my Azure. In my Azure portal, I have already deployed one Azure OpenAI service. And if I just go to model deployment, say manage deployment here. Here I already have few models, few deployment is there. Yeah. So I have used even one embedding deployment, right? I use text embedding ADA 2, and I also having GPT 3.5 Turbo 16K deployment. So I have these two deployment available here that I'm going to connect to my .NET application. And for that, what I need keys as well as endpoint. So now we just go back to this program.cs file. Let me remove this code here, what we have. And even what I can do here is, yes. So just to save the time, let me just copy paste the code here. Say I have say using Microsoft Semantic kernel namespace, what I'm going to use, and I'm just going to create a class, a public class program. So I'm adding the basic class here, and here I'm going to create a method, public static async task main method is there. And here I just create one object here, say where builder is, I'm just going to use kernel dot create builder. I'm not going to pass any argument as of now. So you can see I just create my kernel builder. This allows me to connect to my LLM models later on. Which LLM model? So I have that GPT 3.5 16 turbo deployed, and I have these text embedding models deployed over there. Now I just use builder dot add, and look at this thing. I can use add Azure OpenAI chat completion. Even I can use directly OpenAI, so I can connect to Azure OpenAI as well as I can connect to Azure OpenAI. Both the things, both the APIs over there. So I'm just going to use add Azure OpenAI chat completion, and here I'm just going to provide informations like my model deployment name, my endpoint, and my key, so which I already have here with me. So this is what my deployment name, this is the endpoint of my Azure OpenAI application, and this is the key what I have used to connect to my OpenAI application here. So with this, yes, we have this endpoint, and the connecting of my semantic kernel to my Azure OpenAI is ready. Now I just use this kernel object what we have, say where I create the object kernel is, and say use this builder.build, which will build the object. And now say I just write result is equal to await, and say kernel dot invoke prompt async. Now this invoke prompt async allow me to connect my application to LLM. So whatever message I pass to this method, it will take that message like a prompt and give it to my behind the scene LLM model, which I already deployed on Azure OpenAI. So it's like, yeah, I just want to put a message and say the message says, yeah, give me a list of breakfast foods with bread and cheese. Yeah, that's it. We just make it ready, and whatever result I get, I just want to print. So I just say console log write line, and I just print here what it is, print result as it is. Yeah, so it's done. You can see it's very simple application what we have created here. So it will send this prompt to my Azure OpenAI deployment and get the result. So now let me run it. So I just say .NET run, and we should get the output in a while. Yeah, so here you can see it sent this prompt and we get the response here. So you can see your application is working fine. You just use semantic kernel with the C#, and what it needs, you just write a simple console application in .NET Core. You just add semantic kernel SDK, and that's it. Now you are not going to understand or learn the SDK specific to your Azure OpenAI model or OpenAI model or Hugging Face or what. It is very simple to work with this thing. Right now, with this, say let us start with the presentation again. So with this, we understand how to work with basic understanding of your semantic kernel. Now we are going to understand plugins, how to work with plugins. So these semantic kernel plugins acts like a building blocks of your application, of your AI application. It defines the task that kernel should complete and allows you to interface with LLMs. So when you use this semantic kernel SDK, plugins act as the building block of your AI application. It defines the task that this task you are going to complete and allows you to connect to LLMs over there. Your plugins can include native code, NLP, natural language prompts, and allow you to use Gen AI platform to perform wide variety of tasks. So you can say, okay, take this input and prepare the itinerary, or take this input, convert it to French language, take this email and summarize the email. So summarization is a task that you are going to achieve using this plugin. Or take this context and get the information extract the information out of this context is a task or say connect to this API, or create and open a file, or write data into file, read data from the file, right? These all are the plugins meant for specific tasks, and you can create your custom plugins also. So we have built-in plugins here. It is like HTML plugin, conversation summary plugin, text plugin, time plugin, file IO plugin, math plugin, wait plugin. Various various plugins are there. Again, to work with this plugin, what you need is you need to add a package, .NET Microsoft Semantic Kernel plugins.core package you are supposed to add here, and then you get various plugins. It's like conversation summary plugin allows you to summarize the conversation. File IO plugin reads and writes to the file system. HTTP plugin makes a request to the HTTP endpoint. Math plugin is used to perform mathematical tasks or operations calculations. Text plugin performs text manipulation. Time plugin gets the time and date information. Wait plugin pause execution for a specified amount of time. So these all are the plugins meant for specific goal. They are goal oriented piece of function you have. Even you can see what I did here is I just add that package semantic kernel plugins core particular version, and yes, then here you can see in my code block I just use a time plugin, and time plugin has a function called day of week. So using time plugin I'm going to find out a day of week, right? So look at the function here. I use semantic kernel invoke async function, which takes two parameter, the plugin name and the function of the plugin what you are going to use. Let us see it practically. So let's see the demo now. Yeah. So here I'm just going to create the same file. What we are going to do here is I just copy it and I just paste it here, the new file, to save the time, and say I just rename this one, say program .cs, and I change the class name to program 001. I change the function name to say my time. I don't need its string args and all here. If I just create a static function my time here, right? Again, Microsoft or semantic kernel is there, and I have to install a .NET package for plugins. So I'm going to install a package with particular version, that is, say, one second. .NET add package Microsoft semantic kernel plugins.core, and I want a version 1.2.0 which is available in the preview mode alpha. It is the latest version that I'm going to install. Yeah, so now if I just check this csproj file, I have that semantic kernel plugins.core with version 1.2.0 alpha. It is in preview mode, so it might give me some warning that I need to suppress, right? And if I just quickly copy this code to explain you, because first part of the code is same, but first of all let me add the namespace. So using Microsoft semantic kernel plugins.core, and yes, first part is same. We just create builder Azure OpenAI chat completion API. I'm going to use my model deployment name, API endpoint, key, and now I'm just going to use, instead of this 3 line, now I'm just going to modify this line. I just say I use this builder object and I want plugins. What plugins? So we have the function add from type, and I want to use a time plugin here. So we are going to use a time plugin. It's giving me the warning because it is in the preview mode. So I'm just going to suppress it by say pragma and warning disable. And the code what I'm going to write here is say skex 00p 050. Yeah, it will suppress this warning because when you run it, you get the error code. That code I just put it here, so it will suppress the warning. And now I just use say var kernel builder.build. And now let me ask a prompt. So I just say var current day is equal to await kernel dot invoke async. I need to pass two things. One is my plugin name, say time plugin, and then say day of week. That's it, and I'm just going to display it in console, say current day. It's very simple. So I'm going to use day of week function of time plugin. I just need to call this one in my main file. So I just go to main file here and I just call say what is the class name from 01 dot my time function, and it is an async. So I'm just going to use await here. Let's say I just use await. That's it. So now it will await this one. So now let me run this one again. You can see this is what my first file which gives me the output, but here we have now Friday. It gives me the current day. That is what you can see. We take the input from the user and this AI agent is connecting you to your LLM and you get the power of LLM to your application. Now we see we create one more file here, and now say we just try to get conversation summary. We are going to use one more plugin called conversation plugin. So here we have time plugin and we try to get day of week. Now say I have conversation summary plugin and I just want to understand conversation topic, right? So I just copy paste this file one more time and quickly change it to this 002.cs. I change the class name to 002 here. Rest of the things are same as we already have everything, right? And yeah, now here instead of time plugin, we are just going to add conversation summary plugin. So it is help you to get various aspects of the conversation summary. And say I just put my input, say conversation is okay. So instead of this, first of all, say let me create my conversation, say string conversation. I just write at the rate and I'm just going to paste my content here. So this is what my conversation. It is like I'm a vegan in search of new recipes. I love spicy food. Can you give me a list of breakfast recipes that are vegan friendly? So it's very simple. I'm just going to provide this conversation. And now I say use this result is equal to use this conversation summary plugin. Let me write it to avoid the errors. And what function I want to achieve. So I just want to put get conversation topics. So we have various functions like get conversation summary. We can get conversation action items. We have summarize conversation. So I just want to use get conversation topic, get conversation, say topics. Yeah, and here I just print the result. And I also need to pass the input. So what would be my input here? So I just say, okay, for the input, just pass a new object here. So your input would be this variable conversation. So the conversation, I'm just going to pass in form of an input to this plugin, and I want to get conversation topic. Again, the same way, let me just go back to my main file here. And yes, for time being, let me comment this thing, and I'm just going to use await program 02 dot. Okay, I have not changed the function name. Let me change the function name here. My conversation. If I just go here and I just write dot my conversation. So yeah, let me run it now. So you can see the conversation what I have is, I'm a vegan, I'm in search of new recipes, I love spicy food, give me a list of breakfast recipes that are vegan friendly. So the topics are about vegan recipes, spicy food, breakfast, vegan friendly. Understand, it's trying to retrieve conversation topics from the given conversation. So like here we have used two plugins. We understand conversation summary plugin, we understand even this day of time plugin, right? Apart from these, even we can control our prompt, right? As we all know, prompts are very important, right? And I have separate session that prompt engineering, and you all are aware of why prompt engineering is very, very required, right? You need to provide clear instruction. You have to separate instruction with and instruction from the content, right? You should even ask prompt to justify the design, the justified output, the reason, the reasoning behind the response, right? Chain of thoughts, few short learnings, one short learning, zero short learnings, right? So all these things all these things are various prompt engineering technique, right? So that we are not going to discuss the prompt engineering technique, but what I'm going to do, I'm going to use few of the technique here for writing efficient prompts. So let me create new file here. And this is 003, and I just write, say, my prompts here. Now what I'm going to do, I just want to write an efficient prompt. So after this builder, I don't need these two things as of now. And here, say, I'm just going to create a variable, say string language, and I just want to pass French as a language. Now say, first of all, let us write a basic prompt. So just say, let me show you here. Say this would be your step 1. We are going to write a basic prompt, and the prompt is, say, I just create a string variable, string prompt, and again I start with @. This is the template what I'm using to writing the prompts. We are going to use variables here in the prompt. So every time we get the desired output, right, and just say $. And now here I'm going to put my prompt. So in between these, I just say create a list of helpful phrases and words. Okay, hold on. So let me paste it to save the time. So it says create a list of helpful phrases and words in the language Now again, I am providing French language as a static one, but even you can read it from the console, right? And every time your user pass the different language, you'll get the different output, right? So yeah, but this time I'm just going for with the static language French here, right? And you, as I just provide me this thing, okay, fine, fantastic. And now I just use where result is equal to await kernel dot invoke prompt async. I just pass the prompt here and I just write the result here. So it will take English as a language, it will take this as an instruction, and we get the response. So I just go back to program CS here and let me comment it. Program 03 dot my prompts and let me run it. So as of now, it has executed the first one. And now take a look here. I get around 20 phrases here, which is in the French language. Goodbye, please, thank you is like mercy, oh no, right? So this is what I get the desired output. Now I want to write more efficient prompt. I want to write prompt with, say, instruction. So let me comment this part of code. And we just start with step 2, say writing prompt with an instruction. So now here what I do, again I have the same variable string prompt is just take a look. What I'm going to do is say same thing dollar hold on, yeah. So this is what my prompt is. Prompt is a create list of helpful phrases and words in this language a traveler would find useful. This is what my instruction prompt. And now I'm going to provide some information. The information says I want to group phrases by category and I want to display phrases in particular format like this. So yeah, let me just write it down. Say I just say complete this thing here like this. So here you can see this is what it will create list of helpful phrases and words in English language that travel in the given language the traveler will find useful, group phrases by category and display the phrases in the following format. Hello, so yeah, that is what you are going to pass here. So now even this is same. So I just go to program.cs. The same file I'm just going to run this time. And yeah, so here you can see it grouped by the phrases. It gives me, say, okay, these phrases are for greetings. These phrases are for getting around. These phrases are for eating and drinking, for shopping, for emergencies. So look at this thing, right? It's taking the instruction clearly here, right? This way, even I can define the roles, right? Say you have to act like this, right? And you have to understand the traveler's background, right? So let me comment these things and let me go for the third one. So now I just say step 3 here. What I'm going to do, the language is same French language, but I just write a prompt, and the same way my prompt variable name is prompt, and I just say, hold on, so I just copy it quickly so it save over time. So I just copy it here. So now this time I'm going to read a value from a variable called history that I need to create, right? That I'll tell you why I've not created as of now. And the prompt is says what? Create a list of words that are useful for the traveler, group them by the category, display like this. But I just say consider traveler's background, and the traveler's background I'll get from this history. So here I have a variable, say string history, and the variable says, okay, say I'm traveling with my kids. It says I'm traveling with my kids, and one of them has a peanut allergy. So now when you give me suggestions, please keep this history in the mind. So that's it now. Let me run it again and just see what we get. Yes. So here, what all are the suggestions we get, right? We get those suggestions based on that thing in the mind, right? See, I'm allergic to peanuts. Where is, so that is what, how they have provided me the result over there. Same way, even I can add persona to the prompt. It's like, you have to understand, or you have to talk like an AI agent, or you have to talk like a librarian, you have to talk like an English teacher. So even you can add persona here, right? But what we are going to do, instead of writing this prompt here, we are going to do the same thing with the help of prompt templating, which is very, very important part here. So what I'm going to do here, so I'm going to create a folder. What this folder has, the folder has configuration, because you are not going to write your application like this, right? So what, how your AI agent should behave, what it should consider, what would be your variables, what would be the roles, all those things we are going to read from some external files. How many tokens are allowed, what will be the history of the prompt. For example, how many histories you want to maintain. If your prompt count is greater than 10, then remove the last five, that first five counts, first five prompts, right, from the history. So all those things we are going to define in the separate file, and we are going to read it from that file. So here, for that, you need to create a folder. Folder name is, say, prompts. And inside this prompt folder, I'm going to create few subfolders, say travel plugins, and in this travel plugins, I'm going to create folders like, say, get destination. I just create one more folder, say suggest activities, and I create one more folder, say suggest destination. Now, this each and every plugin folder, they are considered as a plugin, must have two files. The first one is config.json file. Config.json. Here you are going to write configuration specific to your prompts that your LLM has to understand, right? And second file, what you need is skprompt.text. It is like semantic kernel prompt.text. Here you are going to put your prompts. So same way, in each and every directory, I create config.json file and say skprompt.text. And here I also create config.json file and skprompt.text. Okay, right. Now let me just first of all explain you what is there in the config.json file. So I just go to this config.json file of get destination plugin and take a look. Here we have the schema, what type of API we are using, is a completion API or chat completion API. Again, say what will be the maximum token, the temperature parameter value. Temperature parameter value lies between 0 to 2. The value which is closest to 0 means you get the same output again and again, but if it is close to 2, you get more random output. So if you are writing a legal document, you should go for temperature parameter which is closest to 0. But for writing a story or poem, you should have temperature parameter which is close to 2. So here I just say I just want static output every time. I don't want LLM to try new things or I don't want LLM to create creative output every time. What would be my variable name input? It is mandatory, yes. And what would be the description of that variable? So this is what configurations what my LLM would keep in mind. Maximum token is 1200, and I go to escape prompt.txt file. And if you see here, I provide my template, prompt template. I say your role is a system role I'm providing here. Instruction is what? Identify the destination the user wants to travel to. If the role is user is going to going to provide instruction in such a way that I am so excited to take time off work, blah blah blah, right? And if role is assistant, you are going to provide something like the city name as well as the country name over there, and the input variable, the message what you get from the user, that's coming from this input variable. Same way, I go to suggest activities config.json file, and I'm just going to copy paste it. It's the same thing here. This time I change the randomness of temperature parameter. I increase the token to 4000. I also say there should be some history, say background information about the user. That means I'm expecting two input in the prompt. One is the history and second one is destination, right? And again, I'm just going to provide prompt templates here. It is like you have to consider the history and then you have to provide the destination as a response here. And same way we have third one, suggest destination. I just go to config.json. Even here I just go for the same configuration. Token is 1200. This input is the variable, temperature is very close to 0, there is 0.3, and I just provide this prompt text. It is like the following is conversation with the AI travel assistant. So you have to understand you are an AI travel assistant. You are helpful, creative, very friendly, and user can ask like, can you give me some travel destination suggestions? As an assistant role, you are going to start something like very casually. You are going to suggest some question. Do you have budget or any specific activities in mind? So this way you are going to start conversation. So this is what my prompt templating, what I have provided to the prompts. And yeah, then finally, what we are going to do is we are just going to create a file, our prompt file. I just say rename it. Not 34, it's just 4. 004. And yeah, again, rest of the things are the common here up to this point. But now here I'm just going to say, okay, builder is fine. Now I don't need all this stuff. So let me delete them here. Okay. Now, again, conversational summary plugin I'm going to use. And I'm just going to say, okay, I'm just going to say man, I have prompts, and that prompt you have to load. Okay, I'm supposed to write it after this line. The prompt you are supposed to load from, say, import plugin from prompt directory, and I'm going to provide the directories of my prompt. So I just say go to prompts directory, and from there go to travel plugin directory. So from this directory is going to read the prompts as well as its configuration. Then I also create one array. Say we have something called chat history, and say history. It's an empty array as of now. And I'm just going to provide some input. I just write the input here. The input says, say I'm planning an anniversary trip with my spouse. We like hiking mountains and beaches. Our travel budget is something like this. And then again, if you understand, this is about what? This is about suggest destination. It's not about get destination or suggest activity. So I have to go to this suggest destination directory and I have to read this configuration and this prompt template. So for that, I just say here, sure, go to prompts suggest destination directory and you just pass the input here. This is what the input you are going to pass. Variable name is input. If you see here in this config JSON, I say my variable name is input. And here it will understand the role is an AI assistant, as a travel assistant, helpful, creative, very friendly. And it will start with some of the questions and we get some response based on the input. So yeah, that is what here we have mentioned, like this is what the input here. And then I just say, okay, write the result, and I just say, go to a few more questions here. So it is like, I just say, yeah, write the result, and then add that message to the history. If result is not null, then pass the result to AI assistant message. Again, ask one more question. If that is not null, then do read it. Otherwise, it would be empty. And then finally, I just say, again, then invoke suggest activity. From the suggest activities, now here you have two parameters, history as well as the destination that you are going to suggest. So you are going to suggest destinations based on the history. So I'm going to invoke another prompt plugin folder. From that folder, I pass history and input to my config.json file. It will read the skprompt.txt file and give me response accordingly. So here, I think it's done. So let me just go back to my main program.cs file. And what's the name here? Name here is my prompts with templates. I just go to program.cs and say await. Yeah. And I say I don't want to go for these two also. So I'm just going to comment it and let us run now. Yeah. So here you can see what happens. It's saying, okay, so here are few travel destination suggestions for different budgets and interests. It gives me travels destinations like Bali, Paraguay, Cape Town, Kyoto, Buenos Aires, etc. Now say where you would like to go. I just say I want to go to Kyoto, Japan. And it suggests me activities to do in Kyoto. It says, okay, so if you are going to Kyoto, then I suggest few activities, like you can visit this Golden Pavilion in Kinkakuji, you can explore Fushimi Inari Taisha, you can do these things, you can experience traditional tea ceremony, explore John district. So that is what I get all the suggestions over there. But again, this is what, when it's providing me the suggestion, it understands, okay, I need to keep these things in the mind, and I have to also understand the tokens are 4,000, because as prompt is giving me suggestions, I just maximize the size of the token. Even I have just use some randomization here. So if I ask the same question second time, I get the different output, right? But if I have the less token numbers, it will give me the very less suggestions over there, right? So this way you can see, friends, with the help of semantic kernel, you can connect your conventional programming languages like C Sharp, Java, Python with the power of LLM. We are not going to understand the code internals of LLMs. You are just going to understand the semantic kernel SDK. We have various plugins, prompt templating, we have planners, lot of things we can do here. And it allows you to create an AI tool. Like here you can see I am creating this small AI agent. The task is what? Like I am creating an agent for the travel agency which takes the input from the customers and suggests destination, suggests activity. So it is therefore predetermined goal, right? So with these things we have done with our semantic kernel, and this way you can build your own copilot, right? And you can integrate it with the existing travel website of one of your customer, right? So that is what you are building your own copilot with semantic kernel here. I hope you all like the session. Thank you so much.
Thank you so much. This was very detailed. Thank you so much. I am sure a lot of questions will come your way once we send it out to over 1 lakh developers over the period of next 1 week or so. Thank you so
Okay,
much, Mr. Trivedi, for doing this,
thank you so much.
and a happy weekend to you.
Thank you so much. So it was not live, right? I was under the impression that it is live.